everyone. I'll take like 1 or 2 minutes for project questions. Yes, and?
What's the benefit for the cross-site scripting prevention? You say minor modification of PHP program.
Yes.
What's the benefit of PHP over another scripting language?
It's one of the most widely used web application languages. If you want to use that one, just let me know.
So we could use
I think
Python.
that'll be fine.
We
Yeah.
could use Python.
Yes. I think it'd be more difficult, maybe. Possibly. Other questions? Yes.
For the project where we have to generate the payload automatically, do we need to do something like you send a request and like in Burp Suite you capture that request and modify and then send it to the server?
Specifically for which one?
It's for the automatic accesses payload generation.
Yes. So for that,
That would be the project.
for that's the precise one, right? So you want to not just use, so specifically you don't want to just use the list of payloads, right?
Yeah.
You want to understand from the HTML content of the page what characters do I need to execute JavaScript and automatically generate that payload.
So the input would be that request and that target page.
Yes.
Okay.
Yes. And then based on that, you generate automatically a precise payload.
And we can use like vulnerable applications like WebGoat or DAM application.
Yeah, you don't even, for that, you don't have to, you can think of this as a module that you can plug into one of those other tools. Like you don't have to develop all that yourself, but you need to get it so that it is very precise by taking into account the HTML parsing and the context that the output is used in. Yes?
For XSS prevention on server side, we need to do it on server side.
I can't hear what?
XSS prevention on server side
Yes.
implementation. So when we look into Java web-based applications using REST, so the response is always HTML.
Say that again?
If you have a REST API with Java-based web applications,
Right?
so for XSS you need a response to be always HTML so that.
Yes.
So can we go into that direction where the response can be, the request is some way sanitized for Java-based web applications?
Oh, you mean you do it for Java instead of PHP? Yeah, that would be fine. I think it's also more difficult, but maybe, because I think you have less, you may have to use some like reflection, because you need to figure out what are all the parameters that are being sent in for this request, right? It needs to be very dynamic.
Can I use a HTTP servlet dispatcher where HTTP servlet dispatcher, so when I get a request there, I can do a filter and.
Yeah, but you can't just filter because you need to see what's being used, right? If you put it into the database, if it's never used in HTML, you shouldn't filter it. Right? You only need to filter it when it's being output. That's the trick there. It's not just, if you just filter, right, then you're going to filter everything, but not everything is going to be used in a cross-site scripting context.
Later.
Yes, exactly. But yeah, you want to hook the things that are coming in so that you know what came from the user, and then you also want to hook the output function so that way you can properly sanitize anything that needs to be sanitized.
That's what I do.
Yes, perfect. Yeah, that's good. Cool. All right, let's get on with it. Okay, so we've been talking about the web, and we're learning about the technologies that build up the web, right? So that we can understand the web-based attacks. And so we saw cookies. So somebody refresh our memory. What are cookies besides delicious things that we like to eat? What was that?
Key value pairs too.
Yeah, they're just key value pairs, or they're just data that the server asks our user agent to store. And then every time we make a further request to that website or that domain, we send those cookies back, right? And so we saw that there's actually a lot of different policies that the server can specify, so that the server can specify how long the cookie is valid for. And so the user agent, right, the browser is actually responsible for enforcing these policies about expiring cookies and restricting cookies to the proper domains and paths. Right? So can the server force the client to do these things? enforce it to make sure it expires cookies after a certain amount of time? No, right? So actually the server also has to enforce this policy, right? The server also has to check expiration dates and make sure it's expiring cookies and sessions on its side. Also, the user agent is free to delete cookies at any time, right? The user can at any point just delete all their cookies, right? For maybe space reasons or storage reasons, probably not as relevant nowadays with hundreds of gigs of disk space. Or the user decides to clear the cookies. So all of this, the purpose of cookies, right, goes back to sessions, is the website, the server-side code wants to establish some session, right, to understand and talk to the server. So we want some time-limited interaction of a user with a web server so that I can know you're the same user that made this request. And so this is why it has to be implemented at the web application level. So you either have to use cookies, use URL parameters, or hidden form fields. And the most common way sessions are done is the server generates a unique, or in this case unique specifically means random and unguessable, some unique session ID and sends it to the user agent as a cookie, right? And then on the request, the user agent sends back that random unique session ID, and then the server looks up in its database, okay, this is this user, right? So what would happen if I just said, I sent you a cookie that says, hey, your user ID is 1. And then when you send it back, I say, look that up in the database, I say, oh great, it's user 1, here's all your data. Was that good? So will that work to do sessions? Does it functionally work? Yeah, that would work, right? You log in, I set the cookie, I say you're user 1. Every time I get a cookie, I say, okay, you're user 1, here's all your user 1's information. Right? That'll work. What's the problem there? Yeah.
You easily become any user on the system.
Yeah, the cookies live on the browser, right? You could right now go and edit any of your cookies on your browser, and you can just say, well, I want to be user 2, or user 3, or user 4, or any other user on the system, right? Because the server is trusting that you're sending a valid cookie, right? So that's why, in order to be really secure, we need these sessions to be random and unguessable. Otherwise, you can get that. And what also does this mean about the security of this session cookie? So what happens if I'm, let's say, sniffing your web traffic on our local network or on our unencrypted wireless, and I see your Facebook cookie?
I can store and replay it later.
Yeah, if I just store that and I make a request to Facebook using that cookie, right? HTTP doesn't know that it's actually not you that's making that request, it's me. Right? And so this is why actually HTTPS is so important, is because it secures the cookies in transit from your browser to the server. And because cookies are used as session IDs. Okay. So sessions are a key enabling component of web applications, right? We want to have sessions, we want to be able to link different requests together. And so in the early days, in the start of the web, you would write a web application by writing a completely custom web server that would receive HTTP requests and run custom code based on the path, the query data, and would ultimately return a dynamic HTML page. Does that sound like something cool that you would want to do every time you wrote a web application? Yeah? How many people have written a web application? Did you write an entire web server to do that?
There are cases.
What was that?
There are cases.
There are cases? What cases? Who does that?
Box, they actually run a capture the flag system. They designed the entire web application as a web server.
Yes, you can do that. I'm talking about, do people do this nowadays to make a real web application? Right? I would say no, right? And one of the drawbacks is you have to keep, so you have your application, right, that custom code that you want to be executed, but you also then have to keep your web server component up to date with the latest HTTP changes. And you've seen the HTTP 1.1 spec, right? It is pretty long. Yeah? Right? So then every time that spec updates, you would have to update your web application, and everybody on the web would have to do that. So basically, as a matter of abstraction or kind of a separation of concerns, right? We said, okay, let's separate the web server into its own component, and that will accept HTTP requests, then it will forward those relevant requests to a web application to further process. Right? Now you can upgrade the web server and everything will be great, and the back-end web application will be fine. And now you can actually develop a web application, well, without worrying about HTTP is a little bit, without having to parse the HTTP protocol itself. Right? You don't have to worry about supporting all of those different 400 error codes and 500 error codes, right? You can just deal with that. So the basic way I think about web applications is we have our client and we have our web server, right? And the client makes some HTTP request to the web server, and then there's some other web application. It could be on a separate server, it could be on the same machine. That kind of is not quite as important. Somehow that request is forwarded from the server to the web application. The web application does processing, returns some response back to the web server, which then forwards that response onto the client. Cool. So there are a number of different technologies that have gone into web applications. We're just going to look at 2 of them right now, mainly due to time reasons. If we have more time, I'd talk about CGI web applications and how you can write web applications in any language, and it's this really nice older standard. So we're first going to look at active server pages. So ASP, maybe you have experience coding in ASP? Nice. Okay, cool. So ASP was Microsoft's answer to CGI scripts. They said, man, we need people to be able to write web applications, and we want them to use Microsoft technology to do that. So the first version of ASP was released in '96, which is actually kind of crazy when you think about the web kind of started in 1990, and now you have Microsoft creating languages and tool chains for this. And the idea was the program is a mix of text. Like the output that you want the HTML of the page to be, you want text, tags, and a scripting directive that says, hey, at this point in the output, interpret this as either Visual Basic or JScript code. And you could also have server-side includes, like in C, like a pound include. And the idea was these scripting directives were interpreted and executed at runtime. So when you fetched a page, everything that was not a scripting directive would be output normally, but the scripting directives would be executed at runtime. And, I guess we should look up what this is. It's actually still supported a minimum of 10 years from the Windows 8 release date. Actually, it's probably ending closer to the end of life. Oh yeah, October 26th, 2022. I'm trying to think of, is that a long time away? I don't know. It looks like, the date looks like a long time away, right? But I think it's actually not. It's only 6 years away.
Well, when did .NET release their version of ASP?
Yeah, we would talk about that if we had more time, but
And then what's the acceptance rate of that versus?
yeah, I don't know. I think there's probably still a good amount of ASP pages out there. I mean, that's part of the problem of the web, right? Is once you have some kind of technology out there, there's websites that are supporting it and running it, right? So you can't force everyone to upgrade. So let's look at what this looks like. So the basic idea is we have our server directives. Our code is in between these brackets and the percent signs. This tells the ASP engine, hey, at this point, evaluate. Set string name equal to request.queryStringName. And then if string name is not equal to the empty string, then do this constant text, right? So this is outside of the scripting directive. This is going to be constant. Right? But now we got to remember we're inside of an if branch right here. Right? Then we're going to write out response.write string name. So this is going to write out at this location this string name which came from the query string name. And then the else, we have to terminate our if block. So we have an else statement that said you didn't provide a name. And then we're going to end our if statement. So here, writing an application in this way.
You don't have to write like full HTML code.
You don't have to write full HTML code? What does that mean?
I mean, it supports conditional things based on the user input, so you get to provide some logic and not
Oh yeah,
just
so you can, I didn't say it, but you can, this is full-blown VB script, an entire programming language. So you can do whatever you can do in a normal programming language in here, in these, inside these scripting directives. So you have the full power of a language. Yeah.
It's fast. It's fast to code in. It's you can access databases. You can do anything you can do with modern ones. It's simpler. It's easier. It's a little easier to understand how to do some of the dynamic HTML generation stuff because it's all in line, so you can see it in a repeat statement, see how it builds out.
Right, so you can easily see, well maybe not easily, right, but you can see that some of this is going to be output conditionally depending on the conditions, and you can see the conditions right there. What are some of the downsides? Yeah.
Your MVCs, everything in one page.
Yeah, so that's cheating ahead a little bit, but yeah, right, so everything is in one page, right? Do you write, I mean, yes, you can do includes, but I don't know, when you write a normal, kind of largish application, do you put all of your code and everything in one file? No? Right? You think about Facebook, right? If you have Facebook written like this, right, you have to do things like loop over comments and fetch things from databases and do things and create tables, right? So you're mixing in all of this like logic of the application and what needs to happen, and maybe you have some output transformation, like you change people's names or capitalize them or whatever, and it's all mixed in with the output of the HTML of the page, right? So these can, I totally agree this style is a lot easier to get started in and develop things, but it starts to turn into crazy spaghetti code when you have like halfway down your ASP page, you have a database query, which is just like crazy trying to think of everything that happens, right? It's like there's some database query that's happening while you're generating the HTML of the page. But this has some nice things, right? So this request.queryString, so what do we think this does just based off the name?
Get content, get method.
Yeah, get the, in the query, right, of the URL has key value pairs. So this is getting the value of the key that has the name of name, right? And so this is actually kind of nice. So it's providing a bit of a framework for us, the developer, to parse those things and handle all that URL stuff so that we can think of it in a more abstract way. So this is kind of these web application frameworks. So ASP is one example, PHP, as we'll see, is another example. The basic idea is these frameworks try to make it easier for developers to quickly write web applications, right? Oftentimes what happens when you're writing a web application, you're doing the same thing over and over, right? You're trying to get a certain value in the URL string. And instead of parsing that string every time yourself, of looking for the question mark and then separating that into key value tokens separated by ampersands and then separated by equals, right? You can have the framework actually provide all this functionality. And so they can make it easy to extract input from query parameters, from form parameters. They can actually handle all the cookies for you, or say you can have a method called setCookie. Right? You don't have to worry that actually this is going to have to set this header in the HTTP response, and this header has to have a certain format, right? The framework can take care of that for you. Same thing with sessions. You can, a lot of frameworks will provide the ability to handle sessions transparently for you. Oftentimes security, right? So that's actually part of what you're doing in some of you for the projects, right? Is you're providing kind of a mini framework or library or kind of shim layer to handle security for the developers. Even databases, so some frameworks handle talking to the database and fetching data. So now we get to PHP. PHP is a recursive acronym that stands for PHP, the Hypertext Preprocessor. So it is very similar to ASP, so it was a script. It's a scripting language that can be embedded in HTML pages to generate dynamic content. It's similar to JSP and ASP. It was originally released in 1995, as a series of CGI scripts that were C binaries. So this is kind of important because we're going to get into, we're going to look at how PHP, like not how, but the fact that PHP is so popular on the web. And I'm going to look at some of the crazy features that PHP has from a security and understanding what the heck is going on perspective. So it's important to kind of keep this in mind that it was just like a series of C binary applications. And in 1988, PHP 3.0 was released. I think of this, at its peak, PHP 3.0 was installed on approximately 10% of the web servers on the internet in the late 90s. That's 10% of all. Would you love it if any software you wrote was on 10% of the web servers on the internet? Yeah, that'd be pretty sweet, right? PHP 4 was released in 2000, PHP 5 was in 2004. It finally added support for objects, so that there was no way to do objects in PHP. 5.6 was released in August 2014, which is the latest version. So they've been trying to develop like PHP 6. I think they've actually moved on to calling it PHP 7 since it's taking so long. So if we look at the popularity, it is actually kind of insane. So from this company Netcraft, which looks at the usage of web application technologies, the number of, let's say, host names that are using PHP, I mean, this is just in 2012. It's like at, 100 million? And it's actually even above there, it's about halfway through there, so I don't want to think about what number that is. The number of active sites that are using PHP, so PHP is an incredibly popular and used web application technology. It's actually one of those things that it's hard to remember because a lot of times there's a lot more buzz about, I don't know, Ruby on Rails or Django or some of the Node.js web frameworks, all these kinds of things. But it's important to remember that actually PHP is the huge behemoth of the web. That there's just so much more software written for the internet, for the web that uses PHP. Okay, so just like ASP, the PHP page is parsed and interpreted on every page request. So you can run it in CGI mode, so a new copy of the PHP interpreter runs every time a page is requested, or you basically embed the PHP interpreter in the web server so that way the web server knows to interpret every page so you don't have all these instances of the PHP interpreter. This is mod PHP for Apache. If you've ever set this up and enabled this, that's actually what it's doing. It should sound terrifying. You're putting a PHP interpreter inside your web server, but that's the way we do things. It's a completely new and different language. It's C-like in its syntax. And it's kind of, I like to think of it, it's basically like a language that's custom designed to build web applications. And it specifically grew organically over time. So they have a lot of weird things, like you think about modern languages, you want a namespace, right? So that functions that you declare, that way if you need to use database functions, you can maybe include the database functions and use those functions. In PHP you don't have that. You just have all the MySQL functions start with MySQL underscore. And I believe the Postgres functions are the same way. So there's a lot of weird design choices. So let's look at a quick example. So just like in ASP, everything that's not inside of a PHP tag is going to be output constant. It's going to be just output. So here, all this text is going to be output. Everything within the bracket question mark PHP and the question mark end bracket, that's going to be interpreted as PHP code. So this is going to, when this executes, this is going to execute this PHP code. Echo means it's going to return that to the browser, and it's going to output start p tag, hello world, end p tag. Questions? PHP code syntax? Okay, so some of the features of PHP, it's dynamically typed, so this means that you do not have to specify exactly what the types of your variables are. it has string variable substitution, as we'll see. So inside a double quoted string, you can substitute the values of variables at runtime inside that string automatically. You have dynamic includes or requires. So when you include a function, instead of saying like include specifically this PHP code, it actually will, that string that you include can be computed at runtime and can be arbitrary. It has super globals, which are so much better than regular global variables. They have variables. You can have variables that reference variables variably, as we'll see. It has crazy features like register globals, which will automatically create local variables in the scope of your program with the names of parameters that come from the user. Crazy. All right, so let's look at some of these. So string variable substitution. So here's PHP code. We have the start of our PHP tag. So everything within here is PHP code. We're going to echo, this is a simple string. Then we're going to echo variables inside of a simple string. So the single quotes means it's a simple string. But if we set some variables, so in PHP, variables start with a $sign, so that it's kind of nice because they're easy to identify. I believe this came from Perl, is that right? No. Does other language do this? I feel like this came from somewhere else, but anyways. So you can easily tell variables because they have $signs in front of them. And then we can say he drank some $juice. And so because this is in double quotes, this $juice in the string is going to be interpreted as substituting in for this juice in here. And we can even have a really complicated thing. We can make an array of juices, and then we can say he drank some $juices bracket 0 juice, and this will be actually evaluated at runtime. And you can even include the curly braces here to be able to do a substitution based on something complex in here, like any complicated expression that you want. So we haven't got there yet, but some of you have started looking at cross-site scripting vulnerabilities, right? So part of cross-site scripting is when you output something that came from the user. Well here, is it really easy to tell what's being output here? Like what's being output here is a constant string, right? But actually at runtime, part of the string is going to be substituted with a value that maybe came from the user, or maybe did not. Questions on this? So this is kind of an important thing to understand is how they're PHP specific features, but they're features that make it easier for the programmer to write programs, right? But then make it more difficult as our job of, but it also makes it easier for the programmers to make security mistakes and have security vulnerabilities. Yeah?
Could you explain the last statement, the curly braces? What exactly is it?
It allows you to use an arbitrary expression in here. So you can, can you do concatenation? I have to look up exactly what it means, but it means that you can use the single quotes here as for this index inside the juices array. The other thing confusing about PHP is it's arrays and dictionaries are basically the same thing.
Yep.
So this is an array at 0 is apple, at 1 is orange, at 2 there's nothing. The other one is a key, Kool-Aid 1 goes to purple.
Is it the eval in JavaScript?
I have to actually look at it. I don't remember the exact semantics here. I know it's used to do more complicated string variable substitutions. Like you can't just do the single quotes in here because it needs to know that this whole thing is a variable substitution. So this is to say everything within here is a variable substitution. Okay, yeah. Cool, so we can dynamically include or require other code. So this is from WordPress. So this is from the WordPress page, and this is how actually WordPress does themes. So it will load the WordPress environment and template. So it calls require. So just like in C, right? When you include a file in C, it's as if that code is just copied and pasted exactly where you use the include. Right, so this is why if you've ever wondered, in a C header file, you usually have those if not defined tags. That's because when you include a file multiple times, right, that code is just copied in. So if you have one file that ends up including the same file twice, you don't want 2 copies of that code in there. So what's happening is that this code is actually including wp-blog-header.php in whatever the current directory name of __ file is a special PHP variable that specifies the exact current location of this file. So it's saying wherever the directory of this file is, include the thing that's in the same directory as that. So other important things, the dot operator here means string concatenation in PHP, not plus like you're used to, which also frustrates me. So what this means is, looking at this, do you know exactly which file this is going to include? What does it depend on? Depends on what? Yeah, it depends on wherever this file is currently in the directory structure, right? So think about like moving a file around could completely change what this code does because it could include the wrong file. Then the other thing that what happens here is this require is inside this scope here. So it's just like it's copied and pasted in. So any global variables that this wp-blog-header.php file creates, those will be accessible to code after this require statement. And similarly, this wp-blog-header can actually access these variables like this wp-use-themes. This is declaring a global variable called wp-use-themes. So let's look at this example. So it can check if this wp-did header is set. It is not set, so if this does not exist, it will create this wp-did header variable. It will also itself require other files. And then, yeah.
I think something to add here, if I remember right, the $WP header, if you have that in as a header, it automatically does all the headers, puts them into variables for you, so that's automatically done. There's no like query string request.
What do you mean in a header?
Like all your header variables, I think, are automatically done. So your value parameter is the name $. Maybe you're looking at me funny, so maybe I'm misremembering. But I thought that was
I don't know what header variables are though. That's what
like that. So all the things included in the request header are
Oh,
dumped in variables.
We'll look at that. That's a feature that you can choose to enable or disable. It used to be enabled by default.
Yes, that's probably the last time I used it.
Yes.
A while ago.
So yeah, you can see this craziness that it's actually like setting up these absolute path variables and WP include variables to load this template loader library, which probably got set by this WP function. So like trying to even understand not only what the code does, like that's one thing. This is like what code is it actually including so I can understand what this code does, right? Changes and can change at runtime. Okay, some other PHP miss features. Allow URL include is a setting in PHP to allow HTTP and FTP URLs to include functions. So when you set require or include, you could specify a remote HTTP address or FTP address, and then it would, at runtime, go download and make that HTTP request, get that page, and execute that as if it was part of your code. And this setting also you have to enable allow URL fopen, which allows you to call fopen, which is file open, with the URL, and it will do the same thing. It will allow you to read URLs as if they were files on the local file system. And so the remote file will be fetched, parsed, and executed. So, is this a good idea? What could be some problems with this?
If you can somehow change where anything about the TCP
think about it, right? Even if this URL is hard coded, let's say, if it's an HTTP URL, right, that's going to some other computer making an HTTP request, if I can hijack that, I can maybe alter the HTTP content that gets sent back, right? If it's not encrypted, and then that content that gets sent back, it's executing it as if it was PHP code, right? Also, I mean, it's just a completely crazy feature. Like, when you write an application, you want all of your code, you want all the code to live in one place, right? So that you know what this application does, right? If you're including code from some other system that you may not have even written, right, to execute, yeah, that's like crazy dangerous, right? I mean, what happens if you're increasing the attack surface, right? What happens if that other server gets broken into, right? Now if they change that code, your application is going to start executing it, right? And it's not like this is code that just executes on the browser or something. This is something that's executing on your web application that has access by design to all of your users' data, right? Your web application can access the database because it has to access the database, right? But this, now you're pulling in code from who knows where and just executing it. And then, so even if you're not using a constant string, but if the attacker can influence what you're including, then I can make you include my code and execute it on your server. And I've completely owned your PHP application. Okay, so super globals. So this is, let's see. So yeah, okay. So super globals are these $_ variables. These like underscore, $_ get, $_ post, $_ server. These are special variables that the PHP interpreter creates for the PHP application based on the HTTP request. And the tricky part is they're accessible by any piece of code that executes in the application. So for instance here, if you try to, in this WP comments post, if the request method is not a post, then it's going to tell you, hey, I only allow post, and the HTTP response code is going to be 405, and it's going to quit and exit and stop processing. Otherwise, it sets up this variable comment post ID if this $_ post, so this is a comment post ID in the key values that was sent through post. It will interpret that as an integer if it's set, otherwise it'll set it to 0. It's going to get the post based on that. It's going to check if the comment status of that post is empty, then it's going to do some action, and this is some callback that's going to do who knows what, because WordPress is very strange. It's supposed to be very extensible. So anyway, so this is showing that these super globals can be accessed from anywhere. These $_ server, $_ post. Okay. Now we have variables, which are something that I honestly don't know of any languages off the top of my head that allow this. The idea is, on this line I'm creating a new variable called A that has the value hello. On this, now here, the $$ means I'm now creating a variable with the name of whatever's in $A. So this is creating a new variable $hello with the value world. So I can echo A and echo hello, and it's going to output hello world. So this just like automatically created a variable in this scope. It's crazy. Yes, it's super weird. Why would you want this? Just kills me. And then you can access this also in the double quoted strings by using a $, and then curly braces, and then $A. So this will again look up the variable name of something with A, look it up as a variable, what has the name hello, and then output it. Yeah.
It's kind of trying to do like make it easier to do the equivalent of eval in JavaScript or something. We're trying to come up with a way to make it easier.
Look, this is a terrible idea.
Even Python allows this. something similar, dynamic.
Yes, but you have to, at least in Python, it's clear that you're doing something weird, right? Like you have to look up in like globals or locals or something, and you can look through values, and you can do it that way. But I believe all of those start with underscores, right? So that's like implicitly means that that is kind of unsupported. You're digging into the guts of Python here. This is just PHP. Like this is just $2 signs. You're like, this is how we roll with PHP. Yes, and I'm sure it was to more expressivity and that kind of stuff. I'm sure you can do really cool things with this very succinctly that you could maybe not do in other languages as easily. But still, it makes like trying to understand what this does if you see this in an application. You have to understand what could all the possible values be for variable A, right? And if variable A ever comes from the user, then we can control any other value and change their value in the program. So, gosh, it's crazy. Okay, then we get into registered globals. So the idea was, well, man, it's really annoying to have to, whenever I want to access a variable, I have to access like $_post, bracket, tick, variable name, right? It's like, God, wouldn't it be so much better if PHP just automatically created variables based on those names that get sent in? And so it would register all environment variables, get variables, post variables, cookie variables, and server variables as global variables in the scope of your program. So think about what's happening is PHP is automatically injecting variables into your script and the scope of your script based on input from the HTTP request. So the HTTP request, so the variable name, so the HTTP request variable name, right, the key value pairs, is the PHP variable name, and the value is the PHP variable's value, right? So where do the values come from? Yeah, from the user, which is also from an attacker, which means that these can be arbitrarily changed and altered. This was actually the default until 2002. For a long time, this was the default of PHP. And so honestly, when you look at it, it actually does make the code, I'll definitely give this, it makes the code a little bit easier to read. So for instance, let's say I have this feedback page here. So I have some feedback code, and I say if there's a name and if name and comment, then I'm going to open this user feedback file with append only. I'm going to write out name : comment, and then I'm going to close that file. And then I'm going to say, hey, good job, you submitted the feedback. Right? And so in my post method, I'm going to have a form on here with a post with a name and a comment field and a submit button. So now when I submit this, right, it's going to go here, and it's going to automatically create a name variable in a variable called $name in this scope based on whatever the value is here. And then it's going to automatically create a variable comment in here based on this value that I typed in here. So actually this does make it, actually makes it a lot easier to read, right? So we'll actually see in a bit later why this is such a bad idea. Okay. So we talked about, so these are kind of some of the PHP misfeatures, or I'd say features that are probably not exactly what you're used to when you look at a programming language. So we've talked about those. We talked about sessions, right? We want sessions with the user so we can see what they've done. But is that all we want? I mean, do we just want to know that you were the same person as 5 minutes ago? Right? We also want to know, are you the same person from a year ago, from 2 years ago? Right? So what we really need is some way to store the state of the application. Right? We want our users to be able to interact with our application. We want them to be able to save data, information, whatever. And we need to be able to store that. So otherwise, it's really difficult to make a real application, right? Because we have this cookie mechanism, but cookies are fundamentally limited in how much data they can store. I guess not fundamentally. I mean, the browser will limit the size of cookies, right? You wouldn't want it to, like, you visit some website and Facebook's like, oh, here's all posts you've ever written on Facebook. Here's all, 2 gigs of text or whatever. Like just store this and send this to me every time you want to take a request, make a request, right? So where can we store the state? What are some of the options that we have? Thoughts?
Maybe store it in the database and have some unique key that can be used as an
So
identifier.
we can store it in the database. What else? In a database. Where else? Is that the only place we can ever store things? Yeah.
File system?
File system. Yeah, we can store it in files, right? Actually get away with a lot with that. What else?
Memory?
Memory. Yeah, we can store things in memory, right? So we can store things in memory. We can store things on the file system. The file system could be a just flat file system. It could be an XML file. Maybe we store things in an XML file. We could use a database, right? And so the database is the most common, so why?
More structured and easier to access.
So it's structured, easy to access, easier than a file though? It's pretty easy to open a file, right?
Controls around it.
More controls around it, what else? Just like-
Sharing your session across multiple applications.
Yeah, right. So one of the problems with memory is if I want to have multiple web applications, right, multiple copies of my server, they would need to somehow synchronize all their memory so that the state was consistent across all of them, right? But if I have a single database that multiple applications can access, well then multiple copies of the application, then it doesn't matter which server fields that request, they just pull the information from the database. Yeah, there's also a whole host of other databases are their whole other area of research, right? There's a lot of research into making them safe and consistent and fast, and so that they don't lose information, right? Whereas if you do something in a flat file, you may have multiple concurrent requests that overwrite things, right? You basically are implementing a poor version of a database yourself. So yeah, you get ACID compliance, which is great, right? So what does ACID stand for? Atomicity. How's that word? Consistency, integrity, and durability. Good. Awesome. You also get concurrency, right? There's also great separation of concerns, right? So now you can write your application, the database can be a completely different technology, right? And maybe you can swap them out. And you can run the database on a different server, right? You can have multiple web application processes connecting to the same database. What are some of the cons? Overhead in which sense? What sense?
You have to have a database application running.
Yeah, you have to build and deploy and set up a database, and you have to now become if it's just you, right, you have to become an expert on databases and how to use them. As much as we'd like them to be just stupid storage engines, you actually have to know a lot about indexes and all of those things, right, about how to optimize a database.
Also, it's very hard to change tuples. The format that you store it in. It's not essentially backward compatible if you change.
Yeah, so it actually makes, one of actually the very kind of fine things is that it makes, updating your application, right? You want to add some new code or do something. Well, you may need to change some column in your database, right, with an update. But let's say you make that update, but now you need to roll that back because that introduced more bugs, right? So now do you then remove that column? It's not as easy to update and change a database over time as it is to just change the application's code. How do you query databases, normal databases? SQL, yeah. So now you have to know another language. Not only do you have to know and understand HTML, HTTP, we didn't talk about JavaScript yet, but JavaScript, you need to know your server-side language like PHP, and now you also need to know SQL, right? Everything's starting to get crazy. So the classic kind of way this was done is what they call a LAMP stack. So Linux, Apache, MySQL, and PHP. So you have Linux as the server, you have Apache as the web server, MySQL as the database, and PHP as the server-side code. And it's kind of a nice way to think about separating applications into these four pieces because you can easily swap out and mix any of these components, right? You can run this on Windows, and then it's like a WAMP server. You can swap out Apache for Nginx or one of the newer web servers. You can swap out MySQL for Postgres, and you can swap out PHP for also any other kind of language. So yeah, you can completely change all of these things. So MySQL is currently the second most used open source relational database. So what is the first? What is it? Someone guess? Postgres? No.
SQLite.
What was it? Oracle DB? No. Also not open source, but definitely also no.
Lite.
SQL Server? No. Also not open source.
SQLite.
SQLite? Yes. Why SQLite?
Oh, I don't know, I just guessed.
Huh? Not only Android, also iOS. Yeah, every single one of our phones is running SQLite. It's used not only in iOS and Android. It's also probably, I think, used on the Mac in certain places too. So yeah, it's actually really interesting. That's the most widely used database technology.
Why do you have MySQL on the slide over that?
Oh, because MySQL is used more in, so SQLite's really good for like an in-memory, so you get the properties of a database. You can also use it to like go to a file, so it's easy to use in simple scenarios, but it doesn't scale really well to like a complicated multi-process type of thing. So MySQL is much more frequently used in like a real web application sense. Not many people use SQLite for a web application, but SQLite's also really well tested, so it's very, very durable. So MySQL was first released in May of 1995. Actually, a really crazy coincidence is this is the same day that Sun released the first version of Java, which is kind of crazy, but yeah, and also weird because Sun eventually bought MySQL for $1 billion in 2008. So yeah, anyways, I don't know. That coincidence just is super weird, but also really cool. Okay, so when we come back, we will talk. So now we've gone over all the web technologies, right? But we need to store our state somewhere. So now we're going to talk about databases. So you can see that web applications are crazy complex, mostly because of all these different technologies.